Today I want to talk about review for chapter 6. Tomorrow, the Kasha will review chapter 7 tomorrow. So today I want to focus on review for chapter 6. We think about this problem. Find the inverse function of f of x equals ln of 2x minus 3 minus ln of x plus 1. How can you find the inverse function algebraically? Usually we follow the 3 steps. Step 1, write y equals f of x. So like this, y equals ln of 2x minus 3 minus ln of x plus 1. You have to simplify. So why do you have this kind of things? We can use this rule. ln of a minus ln of b. So we have ln of a over b. You can change it like this. Step 2, solve this equation for x in terms of y. I have one question. How can you eliminate ln? How can you eliminate ln? Do you have any idea? How can somebody eliminate ln from this equation? Y equals ln of 2x minus 3 over x plus 1. Okay, so how about other students? You have the same answer? Agree with the other students? Okay, you're right. You can take E, it's like idea. So here you can take the E, the both sides. Take E, the both sides like this. So we have it. So next E and ln and cancelled. We have this one. The next you multiply the both sides by x plus 1. You can multiply the both sides by x plus 1 because on a cross out denominator, so we have like this and cross out. Next, the distribute e to the y into x and the 1 we have left hand side. The next, you have to move the x terms on one side. How can you move x terms on one side? We have 2x terms, x times e to the y, the 2x, so like this. So what's like the best way? So you have to subtract 2x from both sides or x e to the y, both sides, it doesn't matter. Only subtract x times e to the y. So like this, cancelled. So one more, you have to move negative 3 to the other side. You add 3 to the both sides. So like this, 3 is cancelled. What happens? The right hand side is this one. So we have 2x minus x times e to the y equals the left hand side is e to the y plus 3. So we have e to the y plus 3. The next, factor out x. This is same to x times 2 minus e to the y equals e to the y plus 3. Next, divide the both sides by 2 minus e to the y. This one crossed out. So we have this result. X equals e to the y plus 3 over 2 minus e to the y. So we have it like this. The next, step 3, interchange x and y. The resulting equation is y equals inverse of f of x. So what does it mean? Interchange x and y. Replace x by y, like this. The y by x. So that's it. This is the idea. Interchange x and y. So we have it. The resulting equation is inverse function. That's it. This is the whole idea for finding the inverse function. The second one. The function f of x is given. So you need to find inverse of f prime of 6. So how can you solve this problem? You can use this rule. Remember this one? The function f is 1-to-1. 1-to-1. What is inverse function prime of a? So we have this formula, 1 over f prime of f inverse of f at a. This is like idea. This is idea. So first one, you can check function f is 1-to-1 or not. How can you check? So I want to check f prime of x is increasing or decreasing. So what does it mean? F prime is positive number. The function f is just increasing. F prime is less than 0. The function f is decreasing. The increasing function is always 1-to-1. The decreasing function is also always like 1-to-1. This is like idea. You can take the first derivative, f prime of x. The like this one is right. The tan of pi x prime is tan of pi. Sin x prime is cosine of x. Cosine x prime is negative sine x. So what happens? The tan of pi is similar to the tan over 3.14. What does it mean? The approximate equal to 3. The next, what is cosine x minus sine x? Cosine x minus sine x is between the next one, greater than. So this is 3 here, this one. Was it like minimum value? The minimum value is negative 2, is right? Cosine x is negative 1, the negative sine x is negative 1. The exactly negative 2 is minimum value. The maximum value 2. So only add the minimum value. So this value is greater than minimum value 3 minus 2. Like 1. What does it mean? Greater than 0. So we have this result. So function f is always increasing automatically 1-to-1. The increasing function is always 1-to-1. The next, so we can use this formula. Step 1. So you need to find this inside one inverse of f of 6. How can you find? Though we don't know, you can write x, find unknown value. The equivalent to, so we can use definition of inverse function. Inverse of f of 6 equals x is same to 6 equals f of x. So like this, f of x equals the tan of pi x plus sine of x plus cosine of x. This is idea. You can find like this. So let me see. What is x? Do you have any idea? What is x? Just let's find this equation. So could you guess what is x? So could you write your answer on the chatting board? So what is x? The satisfying the equation 6 equals tan of pi x plus sine x plus cosine of x. So what is your answer? So could you write your answer on this one? The pi over 2. The pi over 2 is right. The pi over 2. Okay. Is it right? The pi over 2. You think about it. Yep. Yep. Right. So here, how can you know that? You can plug x equals pi over 2 here. I can plug into here. So what happens? The 6 equals 10 over pi times pi over 2 plus sine of pi over 2 plus cosine of pi over 2. You can check. Pi is crossed out, 2 is crossed out, just 5. So we have 6 equals 5 plus. Sine pi over 2 is 1. Cosine pi over 2 is 0. Yes, we have 6 equal to 0. You're right. This is answer. X equals pi over 2. This one. The next, You can plug pi over 2, x equals pi over 2 into here. What's that? This is pi over 2. What does it mean? Inverse of f over 6 is pi over 2. You plug into here, so we have 1 over f prime of pi over 2. So what's like step 2? Step 2 is you need to find f prime over pi over 2. You can calculate f prime of pi over 2. You plug pi over 2 into here. So we have 10 over pi plus cosine of pi over 2 minus sine of pi over 2. So we have pi over 2 plus cosine pi over 2 is 0. Sine pi over 2 is 1. So this is like 0 minus 1. Sorry, this is like a 10 over pi. Sorry about that. This is 10 over pi. Sorry, the 10 over pi here. So this is the same to 10 over pi minus 1, right? So I will change this one to the fraction. 10 over pi minus pi over pi. So we have 10 minus pi over pi. This is exactly f prime of pi over 2. You plug this value into denominator. Plug into here. What is like step 3? The exact answer of inverse f prime of 6 is 1 over second step. 10 minus pi over pi. You can use reciprocal. Pi over 10 minus pi. That's it. This is final answer. Pi over 10 minus pi. Okay, it's like whole idea. Like this. The next problem. You can calculate limit ln of x squared minus 25. So what is your answer of this question? What is your answer? What do you think? Could you write your answer on the chatting board? What is the answer of limit ln of x squared minus 25 as x approaches 5 from the right? What do you think? What do you think? What is the answer of the first question? Could you write your answer on the chatting board, please? Okay. 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 So far, we have two kind of answers, the negative infinity or positive infinity. What's like exact answer? Negative or positive? Which one? The negative infinity or positive infinity? The positive infinity is right. Positive. Positive. Okay. Why? So why do you have positive infinity? Why do you have positive sign? So could you explain to me the why? So let me see. So we can use graph of ln of x. First one, x value approaches 5 from the right. What happens? X squared minus 25. X squared minus 25 approaches 0 is right here. You can plug 5 into here. 25 minus 25 is 0. What is the ln function? So let me see. This inside one is like log of x. The inside one approaches 0. Inside one approaches 0. Like this. What happens to ln function? ln function is going down. So answer is negative infinity. So really be careful. So by using graph, we have negative infinity. Right? It's good. So really be careful. X value approaches 5 from the right. Answer is positive infinity. No, we don't know. So depending on graph, really be careful. The right-hand limit is infinity. The left-hand limit is minus infinity. No, We don't know. We don't know. You always check. Always check it. So this one. Second problem. How can you solve a second problem? The second problem is the next one. You can use the ln rule. The ln of a minus ln of b is exactly ln of a over b. So we have it like this. Next, you can multiply top and bottom by highest power in the bottom on x, is right? Highest power term is only x. Only divide top and bottom by x, 1 over x, 1 over x. You can distribute 1 over x to the 5 and x, exactly 5 over x plus 1. Similar, you can distribute 1 over x to the first and the second one, the 2 over x plus 3. So what happens? X value approaches infinity, 5 over x is going to 0. 2 over x is going to 0. What's the remaining part? Always keep ln of 1/3. This is the answer. The another one, you can change this form. You don't find ln of 1 is, what's ln of 1? Do you know ln of 1? Okay, okay, okay. You're right. ln of 1 is 0. Answer is negative ln of 3. That's it. This is the whole idea for solving second problem. The next one. What is this one? Oh yeah, you can use L'Hopital's rule. This is possible. So if you know L'Hopital's rule, you can use it. So it doesn't matter because we can learn L'Hopital's rule after first midterm exam. It's like a general rule. So either is fine. You already know L'Hopital's rule. Yes, you can use it. So if you don't know L'Hopital's rule, don't use it. Yeah, it's good. No problem. So how can you solve this one? The limit x minus 6 over x plus 5. So how can you solve this problem? So we use the exponential function. X value approaches 5 from the right. What happens? X minus 6 over x minus 5. How can you do that? You can plug 5 into bottom on and top on. No, this is like a good question. You can use L'Hopital's rule only this case. The limit x value approaches like any number a, the infinity doesn't matter. So we have a fraction form, f of x over g of x form. You plug a into top one and bottom one, we have two kind of forms, 0 over 0 form or infinity over infinity form. Yes, we can use L'Hopital's rule, but other cases, no, don't use. Don't use. We have wrong answer. Only this case, the limit x value approaches a, f of x over g of x is the same to limit x value approaches a, f prime of x over g prime of x. This is like exactly L'Hopital's rule. But in this case, so we cannot use L'Hopital's rule. This is not a fraction, right? Same. You plug 5 into top one and bottom one, what happens? 5 minus 6 over 5 minus 5 is exactly negative 1 over 0. Not 0 over 0 form, not infinity form. Don't use L'Hopital's rule. Impossible in this case. Here, the minus 1 over 0 is always two possible answers. Non-zero over 0 form with one-sided limit. We have two possible answers, positive infinity or negative infinity. How can you decide positive infinity or negative infinity? So you can use one-sided limit. Here, x value approaches 5 from the right. So what happens? The next one. X value approaches 5 from the right. What happens? X value is greater than 5. I can choose one point very close to 5 and greater than 5. I can choose 5.1. you can plug into bottom one. 5.1 minus 5 here. 5.1 minus 5 is positive 0.1. What does it mean? Bottom one is positive. The top one is minus 1, very clear. It's like a negative. Negative over positive is negative infinity. This is a whole idea. Like so. Negative infinity. This is idea. The next, what happens in exponential function? So here, power is going to negative infinity. What does it mean? Power is log of x from the graph. The log of x is going to negative infinity. Going to negative infinity. What happens? Corresponding function values e to the x form approach to x-axis. Y value is 0. So we have 0 like this. So we have 0. The second problem, similar. You can use graph of arctangent. Graph of arctangent is like this. X value approaches positive infinity, arctangent. The arctangent is inverse tangent. The arctangent is going to pi over 2. The x value is going to minus infinity. Arctangent is going to minus pi over 2. We have two possible answers. How can you solve? Same, step by step. X value approaches infinity. What happens to e to x? Here you can use this graph. X value approaches positive infinity. E to the x is going to positive infinity. What happens in negative one? Only take negative both sides, minus infinity. So what happens arctangent here? The inside one approaches to negative infinity. Inside one is exactly log of x-axis. Inside one approaches to negative infinity. What happens? Corresponding function values of arctangent. Arctangent is approach to this dotted line. Y value is negative pi over 2. Like this. So final answer is negative pi over 2. So that's it. This is the whole idea for solving limit problems. Oh, this is like you said L'Hopital rule. So yeah, it doesn't matter. The L'Hopital rule has infinity over infinity. The minus infinity over minus infinity over infinity. The either is fine. You can use L'Hopital rule. Only top one is going to positive infinity or negative infinity. The bottom is going to positive infinity or negative infinity. You can use L'Hopital rule. So only fraction form. It's good. This is answer of your question. It's good. So this is answer of your question. You can write okay. It's not answer. So could you write your question again? Yeah. So we chose a minus infinity. Oh, it's good. Okay. Yeah. Okay. The next one. We are going to next problem. Find the exact values of inverse cosine, cosine pi over 4, inverse cosine, cosine phi pi over 4. So here, inverse cosine, cosine of x is cancellation equation x, but really be careful. What's the domain of x? Domain of x is 0 to pi. Here, really be careful. What? 0 to pi cosine. What happens to sine function? Do you remember? Inverse sine of x is same. You can do cancellation equation just x for all x in domain is negative pi over 2 and pi over 2. So like this. What happens inverse tangent? This one is cancellation equation for all x in open interval, negative pi over 2 and pi over 2. So really be careful. We have a total different. Cosine function, you can do cancellation equation. X is between 0 and pi. Sine function, minus pi and pi over 2. Tangent function, minus pi over 2 and pi over 2, excluding endpoints. Anyway, what is the answer? So could you write your answer on the chatting board? What is the inverse cosine of a cosine pi over 4? What is your answer? The pi over 4? Is it right? The pi over 4? The pi over 4? Okay, I'm waiting your answers. Yep. Okay. Do you have more? Okay. That's good. Yes. Here, the pi over 4. The pi over 4 is between 0 and pi, right? The pi over 4 is between the 0 and pi in the domain. Yes. You can use cancellation equation pi over 4. What's that? Is it right? This is true or false? This statement. True or false? This one. Could you run your answer? No? False? False? Yeah, this is wrong because 5 pi over 4 is not in the domain. It's right, not in the domain. So it's wrong. How can you calculate this kind of things? So we can use, this one is better. Do you remember this one? So all students take calculus. What does it mean? All trig functions positive. Here, only sine function positive, cosine tangent negative, right? Cosine tangent negative. Here, third quadrant, tangent function positive, sine function negative, cosine function negative. The first quadrant, cosine is positive, sine function negative, tangent function negative. Here, the 5 pi over 4 is cosine function. Here, exactly third quadrant. Here, 5 pi over 4. What's that? Cosine is negative. That's right. The which is also negative. Here, second quadrant is also negative. What does it mean? You can change it like this. Here, we have this angle is pi over 4. The 5 pi over 4. So what's that? This flat one is exactly pi. The 5 pi over 4 minus pi is, this angle is pi over 4. So you have to reflect. This segment about x-axis, reflect here. The reflect. This one. This angle is also pi over 4. So what's like an exact angle? From the positive x-axis, we have 3 pi over 4. So what does it mean? Cosine 5 pi over 4 is exactly same to cosine the 3 pi over 4. You have to replace this angle like this. So next, take inverse cosine. The 3 pi over 4 is, yes, in the domain. You have to cancel, answer is 3 pi over 4. This is like the final answer. The next, find the exact values of secant of arcsine of 4 over 5. Simplify the tangent of inverse cosine of x over 3. How can you simplify? So we can use these steps. So this problem first, step 1. You can write arc sine of 5 over 4. Here, the arc sine of 4 over 5. So we don't know this angle, right? Angle theta. Next, you can use definition of arc sine. Definition is 4 over 5 equals sine theta. You can change it like this. Next, you can draw right triangle. The sine theta is opposite over hypotenuse. Opposite is 4. Hypotenuse 5. You can find this x value by using Pythagorean theorem. X squared plus the 4 squared equals 5 squared. Subtract 4 squared from both sides is gone. So we have x squared equals 25 minus 16. We have 9. Take a square root. We have 2 possible answers. The positive 3, one negative 3. Let me see. The length is always a positive number. Only choose positive number 3. So like this. So what's the original problem? Original problem is secant of arcsine. 405. The arcsine 405 is here, angle theta. You can plug into here, secant theta. What is like secant theta? 1 over cosine theta. What is 1 over cosine theta? The cosine theta is adjacent over hypotenuse. 1 over 305 next flip. 5 third. That's it. This is the answer of this question. The next one, here, inverse cosine of x over 3, same. Inverse cosine of x over 3 is theta, in the right, here, the theta. Next, use the definition of inverse cosine. The cosine theta equals x over 3. You can draw, same, triangle. You can draw triangle like this, the same. You can write cosine theta is here, adjacent over hypotenuse. You can find opposite by using Pythagorean theorem. So we have x squared plus the y squared equals 3 squared. Subtract x squared from both sides. So we have the y squared equals 9 minus x squared. You can take square root, the similar. Only think about positive number, the square root of 9 minus x squared. So this is like y. Y is square root of 9 minus x squared. Next, you can plug theta into here. So what's that? This is same to tangent of theta. What is tangent of theta? You can use the definition of tangent theta by using the right triangle, the opposite over adjacent. So we have square root of 9 minus x squared over x. So that's it. This is your final answer. Like this. The next, we think about next part, the differentiation formulas. You need to memorize these differentiation formulas, very useful for preparing your midterm exam. What's a constant prime? Could you write your answer on the chatting board? What is a constant prime? The constant prime is, do you know that? What is C prime? Okay, good. Thank you, all of you guys. Yeah, thank you. The answer is 0. You're right. What is x prime? The same. Could you run your answer? Okay. X prime is, yep, 1. What is xn prime? You can just power rule. N times x to the n minus 1. Or the c times function prime. You can take out constant c. C times f prime. The f plus minus g prime, you can distribute prime, the f prime plus g prime, the product rule. F times g prime is the first function prime times the second one, plus the first one times second one prime. As f of g prime, you can use quotient rule, the top one prime times bottom one, minus top one times bottom one prime over bottom one squared. Sine prime is cosine. Cosine prime is negative sine. Tangent prime is secant square. The cotangent prime is negative cosecant square. The secant prime is secant times tangent. The cosecant prime is negative cosecant times cotangent. So we need to memorize chain rule. The composite function prime, f of g of x prime is outer function prime, like f prime, of inner function g of x times inner function prime, like g prime of x. The power combined with the chain rule, the g of x to the power n prime, like n is log of f. This n is like log of f. Outer function prime, you can use this power rule. So we have n times g of x to the n minus 1 times inner function prime g prime of x. So more differentiation formulas. What's like ln of x prime? Could you run your answer? What is ln of x prime? Could you run your answer? What's ln of x prime? Okay, so we have, 1 over x. Do you know ln of g of x prime? Okay, the g prime of g, you're right. Yeah, we have g prime of x over g. Log x with the base a prime. Do you know that? So you have to use this one. So always use ln of x with the base a is change in natural log ln of x over ln of a. You can take out constant ln of a. Just what's that? The next one. When you take out constant ln of a, just ln of x prime. So we have 1 over ln of a. 1 over x prime is, sorry, ln of x prime is 1 over x, 1 over x times ln of a. It's like a whole idea for solving this problem. The e to the x prime is e to the x. E to the g of x prime is e to the g of x times g prime. Ax prime is, do you know that? What's a to the x prime? Could you run your answer on the chatting board? What's a to the x prime? Do you know? Do you know? What's a to the x prime? Do you remember? What's a to the x prime? Answer is the a to the x times ln of a. The a to the x times ln of a. So a to g of x prime is a to the g of x times ln of a times inner function g prime of x. The inverse sine x prime is 1 over square root of 1 minus x squared. Inverse cosine x prime is negative 1 over square root of 1 minus x squared. Inverse tangent of x prime is 1 over 1 plus x squared. Inverse cotangent x prime is negative 1 over 1 plus x squared. Inverse secant x prime is 1 over x times square root of x squared minus 1. Inverse cosecant x prime is negative 1 over x times square root of x squared minus 1. You need to know this is the differentiation formulas. So we think about this one. How can you find the derivative of FGH? The first one, F first. What's that? This is, you can just split x times ln of x prime minus 5x prime. Next, this one is product rule. X prime times ln of x plus x times ln of x prime minus the 5x prime is only x prime 1, just minus 5. So here, x prime is 1. 1 times ln of x is ln of x plus x times. The ln of x prime is 1 over x minus 5. X is crossed out, ln of x plus 1, negative 5. Final answer is ln of x negative 4. So that's it. This is answer. Right? This F prime, like this. Second one, what is ln of sine square of x prime? This one. How can you do that? Here. Do you know this one? Ln of the something to the power n. This n is always going down. We have n times ln of x. Same. The 2 is like a power going down, not outside, inside. It doesn't matter. Here, 2 times ln of sine of x. You can change it like this. So you can just keep to only ln sine x prime. What's ln sine x prime? Here, sine of x prime over sine of x. Answer is 2 times cosine x over sine of x. That's it. The one more. Do you know identity of a cosine of a sine. What is the identity of a cosine over sine? Could you write your answer on the chatting board? What is the identity? The answer is, okay, I can do it. Okay, okay. Answer is 2 times, yes, cotangent of x. So we have it like this. So what's h of h prime of x? The arctangent of it to 3x prime. You can use chain rule. What's it like arctangent prime? 1 over 1 plus x square form. What's it like this one? You can plug e to the 3x into x times inner function e to the 3x prime. So this is 1 over 1 plus. The 3 times 2 is 6. E to the 6x times, what is it, the 3x prime? The e to the 3x times inner function 3x prime. So we have 1 over 1 plus e to the 6x times e to the 3x times 3. The final answer is 3 times e to the 3x over 1 plus e to the 6x. This is like answer. So wait a minute. What's your answer? Why you square the like a square? You mean the here? This is your question. The here. Okay. Let me see. What is the arctangent of x prime? Arctangent of x prime is, you can use a formula 1 plus x squared. So like this. What is arctangent of g of x prime? Here. So arctangent is like outer function f. You can use chain rule. F of g of x prime. What's f of g of x prime? So we have outer function prime of inner function times inner function prime. What does it mean? You can plug this g of x into here. So we have 1 over 1 plus g of x squared times inner function prime, g prime of x. This is region. You can write like this. Does it make sense? It's good? This is the region. So we can do only right here. The next tip. Find the first derivative of f of x equals log arcsine of root x with base 3. What's like the best way for solving this problem? First, you can use this rule. Do you know this one? The log of x with base a. Always change ln of x over ln of a is better. So what does it mean? You can change ln of the inside one is arcsine of root x here, arcsine of root x over ln of 3. You can change it like this. The next, take derivative. What's it like f prime of x? F prime of x is ln of arcsine of root x over ln of 3 prime. What's that? ln of 3 is constant. Take out 1 over ln of 3. ln of arcsine root x prime. We have it. So this is same to 1 over ln of 3 times what's it like ln of arcsine of root x prime, the inner function arcsine of root x prime over arcsine of root x. How can you find arcsine of root x prime? You can use this Bayesian rule. The arcsine x prime is, we have a rule 1 over square root of 1 minus x squared. So what does it mean? This is same to, you have to keep 1 over ln of 3. And denominator arc sine of root x times what's arc sine of root x prime. You can plug inner function root x into x here. They're like a chain. So we have 1 over the square root of 1 minus root x squared times inner function root x prime. So we have 1 over ln of 3 times 1 over arc sine of root x times 1 over square root of 1 minus root x squared is just x. The square root of x prime is 1 over 2 root x. This is like idea. We have this kind of answers. The next combine. What's that? 1 over the ln of 3 times arc sine root x times, so 2 is here, the take out here, 2 is here. Only combine root 1 minus x root x. So what's that? Times the square root of x times 1 minus x. So we have it. It's like whole idea for solving this problem like this. Is right? That's the whole idea. The next one. How can you find g prime of x? So we can use this rule. The a to the g of x prime. What's like a to g of x prime? So we have, you have to keep a to the g of x times ln of a times inner function g prime of x. So we have keep 2 to the x cubed plus 1 times ln of 2, right? Times inner function prime. This one, we have 2 to the x cubed plus 1 times ln of 2 times x cubed prime is 3x squared. 1 prime equal to 0. You can rearrange. So 3 times ln of 2 times x squared times 2 to the x cubed plus 1. This is like whole idea. The first derivative. What's the equation? Find second derivative. Find the second derivative. How can you find second derivative? You have this one and second derivative. So what's that? Only take out 3 times ln of 2. Just x squared times 2 to the x cubed plus 1 prime. So what's that? You can use product rule. First function prime times second function 2 to the x cubed plus 1 plus first function times second function 2 to the x cubed plus 1 prime. So like this. You can keep 3 times ln of 2. The x squared prime is 2x times 2 to the x cubed plus 1 plus x squared times, what's 2 to the x cubed plus 1? We have it, the top one, exactly this one. 3 times ln of 2, x squared 2 to the x cubed plus 1. The 3 times ln of 2, x squared 2 to the x cubed plus 1. So keep 3 times ln of 2. You keep 2x times 2 to the x cubed plus 1. Yep. So plus here, keep 3 ln 3 times ln of 2. X squared times x squared is exactly x to the 4 times remaining part 2 to the x cubed plus 1. So we have this answer like this, right? That's it. This is your final answer for solving this problem. That's good. The logarithmic differentiation, just like another one. What's that? Here. The logarithmic differentiation is used for finding derivatives of complicated functions involving products, quotients, or powers. Or f of x is g of x to the h of x. What does it mean? We have exponential form. The base is a function. The exponent is a function. We use the logarithmic differentiation. What's that? This example. The really complicated form, like a product, quotient, and powers, like this. Or same, quotient, the square root is like power. You can change it 2x minus 1 over 2x plus 1 to the power 1/2. We can use logarithmic differentiation. Or the x squared plus 1 is like inner function g of x is a function. The power h of x is also a function. You can use the logarithmic differentiation. Like logarithmic differentiation, you can follow 3 steps. Step 1, take natural logarithms of both sides of an equation y equals f of x. Step 2, and use the laws of logarithm to simplify, only expand. Step 2, differentiate with respect to. Step 3, solve the resulting equation for y prime. The y prime is the same to f prime of x. It's like a whole right here. So we can try to solve these 2 problems. How can I solve this one? I want to use logarithmic differentiation. It's like the first one. What's step 1? Take ln the both sides, is right? F of x equals root 2x plus minus 1 over 2x plus 1 is given. Take ln first. So this is same to ln the 2x minus 1 over 2x plus 1 to the power 1/2. The next power 1/2 is like down. The 1/2 ln of the 2x minus 1 over 2x plus 1. One more. This is like quotient form. You can change it to the difference. You can keep this one. Ln of numerator 2x minus 1 plus, minus ln of 2x plus 1. The split. It's like step 1. Step 1. So like this. Step 2. Take a derivative of both sides, right? The first one prime. The last one prime. Only take a derivative. Only take a derivative. So like this. Only take out coefficient 1/2. So we have it here. So what's that? ln of f of x prime is the f prime of x over f of x. Keep 1 over 2. ln of 2x minus 1 prime is we have 2x minus 1 prime over 2x minus 1 minus ln of 2x plus 1 prime is 2x plus 1 prime over 2x plus 1. So what's that? 1 over 2. The 2x minus 1 prime is only 2. 2x minus 1 minus here. The 2x prime is only 2, same. The 2x plus 1 prime is only 2 over 2x plus 1. Next, distribute 1 over 2. What happens? 2 is crossed out. So we have 1 over 2x minus 1 minus 1 over 2x plus 1. We have this is simple form. The next, multiply the both sides by f of x. Here, f of x. F of x is crossed out. Crossed out. F prime of x is f of x times 1 over 2x minus 1 minus 1 over 2x plus 1. Was it like f of x? Change back. Whole thing. going to here. So we have this answer. That's good. This is like exactly logarithmic differentiation. The next two, the same. You can try. How can you do that? Step 1, take ln first. Here, take ln first. You have to expand. So this power x is down, so we have x times ln of x. Square plus 1. Like this. What's step 2? Step 2 is take derivative of both sides. This one. Take derivative of both sides and calculate. What's like the first one? This one is y prime over y. This one is product rule. X prime times ln of x squared plus 1 plus x times ln of x squared plus 1 prime. So we have x prime is 1 times ln of x squared plus 1 plus x times ln of x squared plus 1 is x squared plus 1 prime over x squared plus 1. So we have this result here. Y prime over y equals ln of x squared plus 1 plus x squared plus 1 prime is same to only 2x. So x times 2x is 2x squared over x squared plus 1. Just like step 2, right? Like this. Step 3. What's step 3? Yep. So I want to finish this problem and explain your equation here. Only multiply the both sides by y, is right? Only multiply the both sides by y, like this. The y is crossed out here. What's like y prime? The y is changed back, original one. Y prime is x squared plus 1 to the power x times remaining part ln of x squared plus 1 plus the 2x squared over x squared plus 1. So that's it. This is the answer. But I want to answer your question. How do you know if the problem is a logarithmic differentiation type or not? So answer is here. So when do you use logarithmic differentiation? Here we have case 1. Case 1, complicated functions involving products, quotients, power. Here, the products, quotient, power. This is same to 2x minus 1 over 2x plus 1 to the power 1/2. This is complicated form, like quotient and power, is right? Quotient and power, you can use logarithmic differentiation. The second case is here. Function f of x is exponential function. The g of x to the h of x here. Y equals g of x to the h of x. The g of x is function. H of x is function. You can use logarithmic differentiation. Here, 2 to the x don't use logarithmic differentiation because 2 is not a function of x. In this case, you can use just the rule. The 2 to the x ln of 2 times, so that's it. Only 2x, 2 to the x times ln of 2. It's good? This is the answer of your equation. It's good? Here, the next one, the last part is the integral problems. You can deal with the integral problems in the chapter 6. The tomorrow, the Kasha will deal with the more integral problem in chapter 7. I only focus on the basic integral forms in chapter 6. Here, so you need to memorize this integration formula. Integral k dx is kx plus c. Integral x to the n dx is 1 over n plus 1 x to the n plus 1 plus c. In this case, n is not equal to minus 1. Integral 1 over x dx is, so do you know that? Could you run your answer? What's integral 1 over x dx? What is your answer? Could you run your answer? ln of x? Unfortunately, wrong. Not ln of x. So what is the answer? Not ln of x plus, yes, absolute value of x. You're right. Yeah, ln of, really be careful. Absolute value of x plus c. Absolute value of x plus c. The integral g prime of x with g of x dx. What's that? ln of absolute value of g of x plus c. So one example is we have this kind of problems. Integral 2x over x squared plus 1. What's the answer? So x squared plus 1 is like g of x. The 2x is g prime of x. Exactly. ln of absolute value of x squared plus 1 plus c. One more. X squared plus 1 is always a positive number. In this case, we don't need absolute value sign, change parentheses. It doesn't matter. It's like idea by using this rule. Integral e to the x is e to the x. What's integral e to the kx? Do you know that? Really be careful. What's that? 1 over k e to the kx. So one more example is integral e to the 5x dx. How can you calculate? 1 over 5 e to the 5x plus c. This is idea. The h to the x dx is h to the x over ln of a. So what does it mean? Integral 5 to the x dx is 5 to the x over ln over 5 plus c. Do you know what's the 5 to the x prime? The 5 to the x prime is 5 to the x times ln over 5. So really be careful. We have totally different answers. Totally different answers. The integral sine x is, yep, I can slow down, okay. Integral sine x dx is the negative cosine x plus c. So do you know this one? What is integral sine 5x plus the dx? What's that? So could you run your answer on the chatting board? So what is integral sine 5x dx? So could you write your answer? The negative cosine 5x5 plus c. You're right. Always, yes. 1 over 5 keep negative cosine 5x plus c. Yes. So we have general form. What's integral sine kx dx? So we have the negative cosine kx over k plus c. So you need to know the general form is better for solving this problem. Integral cosine is the positive sine x plus c. Integral secant square is tangent x. Integral cosecant square of x is negative cotangent x. The integral secant tangent is just secant. Integral cosecant times cotangent is negative cosecant. Do you know integral tangent? Could you run your answer on your chatting board? What's integral tangent x? So could you run your answer? Tangent x secant x plus c? Secant square plus c? Secant square x plus c? So really be careful here. What is tangent prime? What is tangent prime? Yes, secant square of x. Secant square of x was integral tangent ln of absolute value of secant. How can you know that? So we can use sine of x over cosine of x dx, you can just use substitution. The u equals cosine of x, the du is negative sine x dx, right? So you can multiply the both sides by -1. Negative du equals sine x dx. Like this. So we have integral 1 over cosine x is u. The sine x dx is negative du. So like this. Take out negative 1 minus integral 1 over u du. The negative ln of absolute value of u plus c. You can change back. U is cosine. So we have negative ln of absolute value of cosine x plus c. The -1 is going to top. The ln of absolute value of cosine x to the power -1 plus c. You can change it. Cosine x to the -1 is 1 over cosine. 1 over cosine is here, secant. So that's it. This is idea. Anyway, you can memorize. This rule is better. So what's it like integral cotangent x dx? Similar. Only difference is ln of absolute value of sine x plus c. Do you know integral secant x dx? Do you know what's integral secant x dx? So I don't explain this procedure. This is like a formula. ln of absolute value of secant x plus tan x plus c. Cosecant x dx is ln of absolute value of cosecant x minus cotangent x plus c. Let me see. You don't need this one. You don't need it. Only memorize this one. Tangent x is ln of absolute value secant. Integral secant x dx is ln of absolute value of secant plus tan. You can memorize these two things. Next, do you remember? What is the answer of this one? Do you remember this one? Could you write your answer on the chatting board? Sine. Really be careful. Inverse sine of x of a. Or the another notation is, let me see. You need to try to solve only multiple choice problems here. Inverse sine of x of a, or it doesn't matter. Another notation, arc sine. The arc sine of x of a plus c. So we have this kind of things. So remember this one? Was integral 1 over a squared plus x squared dx? So what is your answer? Yes, answer is 1 over a inverse tangent of x of a, or 1 over a arc tangent. It doesn't matter. Arc tangent of x of a plus c. So really be careful. We have 1 over a. This is like a key. The one example is integral 1 over square root of 2 square minus x square dx. You can use this formula exactly. Inverse sine of x over 2 plus c. But integral 1 over 2 square plus x square dx. What is the answer? Always 1 over 2. Inverse tangent of x over 2 plus c. So really be careful. The inverse sine, inverse tangent, really be careful. Inverse sine, we don't have any coefficient. Inverse tangent, yes, we have a coefficient. Really be careful. So this problem. So how can you solve this problem? Do you have any idea for solving this problem? So do you have any idea? Do you have any idea for solving this problem? So what kind of formula do you want to use? You can distribute. Okay, distribute. So what's that? can distribute this one like this. What's the next step? What's the next step? How can you solve? No. No problem, no problem. You can do only something like the write your like equation. I love it. I love something you try. Don't worry, just try. So thank you for your some any kind of like answers. It's good. It's good. You can only attend my class. Participation is really good. It's really good. Don't worry about it. So yeah, you can only try. This is like doesn't work. Was it like the best way? Yes, you can use substitution. Was it like a U substitution? Here, what is root x prime? 1 over 2 root x is right. 1 over root x is here. So what does it mean? The root x plus 1 is like u. This is like idea. So you can use these two kind of things. Use what? Here, root x plus 1. What is tu? The square root of x plus 1 prime is 1 over 2 root x is right. The tu is here. Tu is the root x plus 1 prime dx. The root x prime is 1 over 2 root x and dx. So we have it. So next, this one doesn't have a 2. You can multiply the both sides by 2. 2 is crossed out. 2 du equals 1 over root x dx. Next, substitute. How can you do that? Here. The root x plus 1 is here u. The 1 over root x, the du is 2 du. Here is right, 2 du. One more, you can change lower limit, upper limit by using this relation g of x. You plug 1 into here, g of 1. You plug 4 into here, g of 4. So we have integral. What's like a g of 1? You plug 1 into x, the square root of 1 plus 1 is only 2. You can plug 4 into x, the root 4 plus 1 is 2 plus 1. We have 3. So we have take out 2. So here, 1 over u du. So we have, yeah, it doesn't matter. Don't change lower limit, upper limit. Just the only solve 2 times integral 1 over u du. Find ln of absolute value of x, change back, u equals root x plus 1. Next, plug 1 and 2, 1 and 4 later. In the end, it's good. Yeah, it doesn't matter. You're right. Yes. You can do it. You can do it. Yeah. So 2 times this one is ln of absolute value of u from 2 to 3. So 2 times ln of 3 minus 2 times ln of 2. Here, 2 is going to power. The 3 squared is 9. The 2 is going to power. The 2 squared is 4. Next, combine. Ln of 9 over 4. That's it. This is the final answer for solving this problem. So, like this. Here, how can you solve this problem? So what do you think? So what kind of method do you want to use for solving this problem? The U sub again? U sub? The U sub? Okay. Well, U is, yes, sine function. You can use U substitution. U is sine function. You're right. What is du? Sine x prime dx. Exactly. The sine x prime dx. So we have cosine x dx. So we have it like this. So next, substitute. Here, integral from 0 to pi 2, can change it later. The sine of x is here u. Oh, how can you decide like u? The only like try. The one example is here. You can choose e to the sine of x is like u. Only take derivative. So we have e to the sine of x times cosine of x, but we don't have it exactly. Cosine x of e to the sine x is not good choice. Only inner function. The e to the sine x is outer function. Sine of x is like inner function. Only try the sine x prime. Sine x prime is cosine x. Yes, we have it. This is good choice. This is idea. You can take a derivative. The derivative is integrand. This is a good choice for finding u. Yeah, only trial and error. You're right. Yes. The e to the u. The cosine x dx is here, du, 1 times du. The one more, I can change it to the negative exponent like this. Another one. You can change here. Plug 0 into this one, the g of 0. You plug pi over 2 into here, g of pi over 2. What is like g of 0? The g of 0 is sine of 0. The sine of 0 is 0. You can plug a pi over 2 into x. Sine of pi over 2 is just 1. And du. How can you do that? You can use this rule. So what does it mean? E to the minus u is same to what? Negative e to the negative u from 0 to 1. So you can plug 1 into u minus plug bottom on minus 0. This is negative 1 times e to the minus 1 is 1 over e to the power 1. The negative is positive. The e to the 0 is just 1. So we have 1 minus 1 over e, right? 1 is here. Minus 1 times 1 over e is negative 1 over e. So we have like this. This is the whole idea for solving this problem. So like this. Right? So here, what's that? How can you solve this problem? So what kind of method do you want to use for solving this problem? Could you write your method on chatting board, please? So which method is the best way for solving this problem? What do you think? So do you have any idea for solving this problem? So what do you think? How can you solve this problem? Tangent formula? The trig formulas? What does it mean the tangent formula, trig formula? The like you said the trigonometric substitution, you said? Like a tangent theta or something like that, you're right? Tangent function? Yeah, this is one idea, but when you use the trigonometric substitution, only power is 2, but power is 6. So what does it mean? You can change it better. Like so. Integral from 0 to cube root of 2 x squared over change it 4 plus x cubed squared. You can only think about relation between inner function x cubed, numerator x squared. What does it mean? The inner function x cubed prime is the 3x squared. Yes, we have x squared from here. What does it mean? You can use u substitution is one good idea. What's it like u? U is inner function x cubed. The tu is x cubed prime. Tx. So we have the tu equals 3x squared dx. The integrand doesn't have a 3. You can divide by 3. So answer is the 1/3 du equals x squared dx. The next, You can write this is like a function g of x, like this. So if you use trigonometric substitution, so what does it mean? We have constant square x square form. Only power is 2. You can use it. One example is integral like square root of 4 plus x square and x square dx like this. Inside one has x square form. In this case, x is 2 times tangent theta like this. But power is like 6 or something like that. It's not good. So don't use like the trigonometric substitution. Yeah, always use power is 2. This is a good idea. The constant plus power square. Sorry, x square form. It's good. The use substitution is only like change it to this kind of form. You can check. Inner function is x cubed. Outer function is 2. You can take inner function prime. Inner function prime is 3x squared. X squared is exactly numerator. It's a good choice. You can use substitution. Just like idea. You can decide tricks of or use substitution. So my point is you can try use substitution method first. It works, you can use it. Doesn't work, you think about other kind of method. Like better. It's like better. The first trial is the use substitution. Failed, you can use other method. Integration by parts, what trigonometric substitution, and so on. You can learn the more skill, the more like possible, the good decision for using the method from the Kasha. Tomorrow, you can only take it. So the Kasha's class tomorrow, she will explain the more skills, the more idea for deciding the exact method. Anyway, this is like the one method for solving integral problems. So you can going back to this problem again. So what's that? The integral, you can change. This is g over 0. G over cube root of 2. So this is x cube is u. You plug here the 4 plus u square. The x square dx is exactly 1/3 du. Here only du is 1. Only take out 1/3. The 1/3 du. The next, how can you find this one? You can use formula 1 over the a square plus x square dx is 1 over a inverse tangent. Inverse tangent of x over a plus c. You can use it. So, but you just only change it a little bit. You plug 0 into here. The 0 cube is 0. You can plug cube root of 2 into here. What's that? The cube root of 2 cube. We have only 2. The cancelled. Top is like 2. 1 over the 4 is 2 square plus u square du. You have to keep 1/3. Find antiderivative 1 over 2 times inverse tangent of u over 2 from 0 to 2. You have to keep 1 over 6. You can plug 2 into here. What's that? Inverse tangent of 2 over 2 minus inverse tangent of 0 over 2. So you can calculate. First one, what is inverse tangent of 1? Do you know that? What is inverse tangent of 1? Could you write your answer on the chatting board? What's that? The pi over 4? Is it right? Yes, you can use this one. So you can use the definition tangent theta. So like this. So which angle has a tangent 1? Angle theta is pi over 4. So you have 1 over 6 times pi over 4. What's inverse tangent of 0? Similar. Inverse the tangent of 0 equals angle theta. You can use definition 0 equals tan theta. So angle theta is exactly 0. So this is going to 0. You're right. So answer is pi over 6 times 4 is 24. This is whole idea for solving this problem. So next idea, so like this. So how can you solve this problem? How can you solve? What kind of method do you want to use? The first problem. You can use which method do you want to use for solving integral 1 over 1 plus x squared arctangent x dx? What's like the best way? Use up? Yes. What is u? What is u? Yes, arctangent, because arctangent prime is 1 over 1 plus x. The 1 over 1 plus x square is in the integral. This is like idea. U is arctangent. The du is arctangent prime is 1 over 1 plus x squared dx. Next, change it. Here, what's that? This is same to integral 1 over. The arctangent is just u. 1 over 1 plus x squared dx is just du. So we have ln of absolute value of u plus c. So what does it mean? Isn't u supposed to be what's in the parentheses? Oh, the parentheses. So this is different. What's that? The depending on problem. Let me see. The previous one is here. What's that? You can change it. X to 6 is like a parenthesis squared. What does it mean? It's a composite function. The 2 is outer function. X cube is inner function. In this case, choose inside one inner function. But here, this parenthesis is we don't have any power, not composite function. Not composite function. So in this case, don't choose 1 plus x squared. So in this case, arctangent. This is totally different. Yeah. The du is like this one. So we have like this. Next, change back. U is arctangent. You plug into here. Answer is ln of absolute value of arctangent x plus c. So we have it. So like this. This one. So what's it like u in this case? You can use substitution again. What's u here? What's u? Arcsine, yes, this is arcsine. You have to use like inverse sign, like arcsine is like u. The du is the inverse sine x prime is 1 over square root of 1 minus x squared. Same, you can split like this. You can plug. Inverse sine is u into power. So we have integral 5 to the power u. The remaining part is like du. So we have du. So find answer 5 to the u over ln over 5 plus c. You can change back. Inverse sine of x into u. We have the 5 to the inverse sine of x over ln over 5 plus c. It's like a whole idea for solving this problem. The next thing. The last problem. So let me see how can I solve this problem. How can I solve this one? The first one, the log function is not good. The always change what? Log x with the base a, change ln function is better. ln of x over ln of a. It's like better. So what does it mean? You can change. Integral. Was it like log x with the base 2? We have 1 over x times. This one is ln of x over ln of 2 dx. 이네거 E, the E square, 1 over, what's that? X times ln of X, X times ln of X over ln of 2, dx. The next reciprocal. The ln of 2 over X times ln of X dx. ln of 2 is like a coefficient, take out 1 over ln of 2. 이네거 이 2e square 1 over x times ln of x dx. So let me see. How can you solve this problem? Which method is better? E equals ln of x is better? Is it right? How can you know that? It's the same things. You can choose ln of x is like u, take a derivative. ln of x prime is 1 over u, 1 over x. The 1 over x is here. It's good choice. It's good choice. ln of x is like u. Do we have it? So what's that? The u equals ln of x. You can write this like g of x. The du is the ln of x prime 1 over x dx. So you can change. Keep 1 over ln of 2 이네거 g of e squared. Here 1 over the ln of x is here u. The 1 over x dx is only du. This one. Keep 1 over ln of 2. What's g of e? You can calculate g of e. You plug e into x. ln of e is 1. What's g of e square? Plug e square into x. ln of e square, ln e cancelled, only 2. So like this, 1 over u du. So we have 1 over ln of 2 times, what's that? ln of absolute value of u from 1 to 2. Oh, sorry, my mistake. Could you find my mistake? Here, only take out ln of 2. Oh no, we don't have a fraction. Sorry about that. So we don't have a fraction. Just ln of 2. Sorry about that. Here, ln of 2. ln of 2 times ln of u from 1 to 2. Keep ln of 2. Only plug 2 into u. The ln of absolute value of u is exactly same to ln of 2 minus plug 1, ln of 1. The ln of 1 is 0. So answer is the ln of 2 times ln of 2. So my equation, ln of 2 times ln of 2 is ln of 2 square is makes sense to 1. What do you think? Is it right? Is it correct? No? No? What do you think? No? Yes? No? No. Here, 2 times ln of 2. 2 is going to power, yes, ln of 2 square. What does it mean? Don't write. ln of 2 times ln of 2 is only ln of 2 use parentheses squared. So like this. This is your final answer for solving this problem. Okay, so this is all for today's lecture. You can learn the more skill for solving integral problems tomorrow from Kasha. Any question? Could you write your education to me so I can explain to you? Law of logs, yeah, you need to know this is very same to the laws of ln, right? Yeah, this is no difference. You need to memorize these rules the good for preparing your midterm exam. Here, one example is ln of you said what's that? The revise? Was it like a revises? So yeah, you can only some upload my lecture note on Canvas. Yes, this review packet on Canvas. You can print now. Exactly same to my lecture note. Yeah. The ln of x plus ln of y equals ln of x times y. The same. The general log function log x with base a plus the log y with base a is same. The log x times y with base a all the same. Here, the log x with base a minus log y with base b is the log x over y with base a. The last one is log x with base a times r. R is going to power. We have log x to the power r base a. Yeah, always the same to the ln function. Always the same. So you need to know that these whole kind of rules, like the good idea for preparing your your first midterm exam. Okay. So if you don't have any question, you can leave a live session. So if you have any question, just write on the chatting board. I will do my best to answer your questions. Yep. Okay. So more questions, just write your question. You don't have question, you can leave live session. Yeah. I'm just waiting. Okay, you're welcome.